Okay, welcome to chapter 12, second video. We're going to talk about the properties of alkanes today and addition polymers. As we talk about properties of alkenes, we've got to look at the chain length. As the chain length gets large, so down here at the bottom we've got small, and we're heading up to large. If we think about melting point generally gets higher as far as temperature goes. As we get larger. Well, think about that. At room temperature, methane's a gas. At room temperature, octane, which we put in our car, is a liquid. And at room temperature, candle wax, which is around C42, is solid. So it's going to take more energy or be a higher temperature to melt. Same thing goes with boiling. As I get longer and longer molecules, it takes more and more energy to get it to boil. Okay? Density goes up because I've got more and more carbons packed into an area. I have less space. Let's go on. We have what's called addition reactions when we talk about alkenes and alkynes. But what happens is a compound, let's say AB right here, comes in and it will break up a double bond because a double bond's a little stressed and it likes to be single bound. And the compound will attach like this. Let's take a simple one like C double bound C, C plus HCl. As we put this in, what will happen is it will become C, single bound C, Cl, C. Now how did I know where to put the Cl? That brings us to our next slide. It's called Markovitch. I'm sorry if I said it wrong. I am not. I think it's Russian. I'm not sure. But we'll just call it M's rule. When HX adds to an alkene, the hydrogen becomes attached to the double bonded carbon that already has the greatest amount of hydrogens. The rich get richer. Just remember that. The rich get richer. So as I look at this and I come in here, let me get a nice skinny pen. This carbon here has 2 hydrogens. This carbon has 0. So the hydrogen, the carbon that has the most hydrogen gets another one. And the carbon that has the least gets whatever's left over. So that's why we end up right here. If I look at this next one coming down here, you'll notice that this carbon on that corner right there has 0 hydrogens. This one on this corner has 1. So when the HCl comes along, the H gets to go on this side where the Cl goes on this side. Hope that makes sense. Just remember the rich get richer when it comes to hydrogen. Now, if we break this down, we have 3 main kinds of addition reactions: halogenation, hydrogenation, and hydration. Now, hydrogenation and hydration sound a lot alike. Just remember, hydrate. If you're going to hydrate somebody, you're going to put water into them. That's what you do with hydration. With hydrogenation, you're putting hydrogen into the compound, and that's it. So hydration, water, hydrogen, H2. And halogenation is anything in the halogens. That could be fluorine, chlorine, bromine, iodine, and remember those all come in 2s. Okay? So with the halogenation, you just put 1 on either side of what used to be the double bond and you're good. With hydrogenation, same thing. You just put a hydrogen on each side. Now you've heard of like Crisco's hydrogenated oil. Peanut butter sometimes is hydrogenated. They're putting hydrogen in, breaking up some of those double bonds and making them single bonds. That makes things thicker. Okay? Hydrogenation, putting water in, will help me form alcohols and things like that. Again, with hydrogenation, you need to watch out. You need to use Mr. M's rule, and the hydrogen will go on the side that already is hydrogen rich, and the OH will go to the side that's not. Okay, pretty straightforward. You just put it on either side. Now we're going to get into polymers a little bit more. In order to understand polymers, you need to understand monomers. Monomers are the group that we make polymers from. So when you think of mono, mono means one, mer means part. So one part. A monomer is one part of a polymer. A polymer is many monomers together. So we can start with ethylene. Remember the smaller double bound things keep their YL, methylene, ethylene, propylene. And then when we get to butene, it doesn't. Okay? So if I put ethylene in high pressure with heat and catalyst, the double bonds between the two carbons will break and it'll attach to other double bound groups that then become single ground groups. So we have this whole big chain and we call it polyethylene. On the bottom one here, we have vinyl chloride and vinylidene chloride. And like I told you in class, you know, organic names were never really made to say out loud. They're just to tell us how to make them. If we pair these two together, then we get saran wrap. And you can see how the structure goes together, breaks up, hangs together. And every time there was a double bond, what actually happens is the double bond goes away. These two attach, make one group, and then this group attaches to many more groups like it. That makes polymers. Polymers are really, really important. We use them in lots of different things. We use them in hoses and any plastic that you've got, including coolers and paints. And the list just goes on. There's a huge list in your book, and you can go there and just see. We have a lot of important monomers, and the monomers help us make polymers that last longer. Now, on that same process, we're now looking at, now that we've got all these monomers, that are all these plastics, that are all these styrofoam and things that we've made that were really cool, well, now they're not breaking down in the environment. Now we're looking at ways to try and figure out how to break up those polymers that we've made so that they can be reused, so that we can make new things out of broken things. All of this is up and coming in your world. Okay, we'll see you in class.